Hello, EFR 515 students. Today we're going to be talking about Chapter 17, which is the chi-squared goodness of fit, test of independence. And we have an example here, and it's drawn from the text on page 610 of the text. But the chi-squared test is very valuable for us, has lots of uses. The text starts talking about parametric and non-parametric statistics. And parametric just means that it assumes the underlying parameters of a distribution. So if we're doing a t-test, for example, we're assuming that the errors associated with that test are normally distributed in some way. So it assumes a distribution or the parameters of a distribution. In non-parametric, we're not assuming parameters in that analysis. So these are big two types of tests we'll see. So the text talks about some of the applications. We'll see chi-squared show up quite a bit, but in this assignment, really want to focus on the idea of the test of independence, and that's probably the one you're going to see the most using the chi-squared and its analysis. So really it's the test as we see in the definition on page 605, the chi-square test for independence. And that's what we want to focus on here. And again, this example is coming from the text on page 610 of the text. So we're interested to know is there an association in this case between willingness to use mental health services and sex, males and females? And there's count data within this table. And the assumption of the chi-squared is the observations are independent and the expected frequencies are greater than 5 for each of the cells. And we'll talk about that a little later on in the analysis. So I say enter the below data in the SPSS, conduct a test to see if there is evidence of a relationship between sex and willingness to use mental health services. Write up your results in APA format, and we're given the write-up for this example on page 615 of the text. When I'm looking at it here, they got their n wrong. They put n of 50. It really should be n of 150 in conventional way to describe this test. So let's go ahead and do this in SPSS. So we have our observations up here, and that's where you're normally going to see these tables. But there's a couple different ways to enter in an SPSS. But if we're just given bare count data here, what we need to do is enter it something like this. So I've reconfigured this table here where we have sex, males, 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 females, females, females. So coming across this first row is the data. So the 17 here went to here. The 32 here went to here. And these represents counts or frequencies within the observations. So I put that center table and reconfigured that there. So once I have this, now then I can go ahead and start thinking about entering it into SPSS. So I'll grab my data set in SPSS here. And I want to be on not the variable view, but the data view. And I can go ahead and grab, you can type this in by hand, but I'm just going to go ahead and grab this data here, copy it over in my SPSS, and paste it right in there. And then I'm going to go ahead and label things there. So we have sex, and I abbreviated here willingness to use health services, and we have count, the count data. And I did that in variable view. So I go back to my data view now. Now I have to do one thing before I run this analysis in SPSS is I have to weight the data. So I'm going to go data, and then I'm going to come down here to weight cases. Weight cases. So data, weight cases, and I'm going to weight the count. So weight by case, I click on that, and I'm going to bounce over count. I'm just going to say OK. That's going to show the log that says it did that. I'll go back to the data file. And you might have to come down to your tabs down below in order to find these windows. Once I'm there, I'm going to go ahead and do analyze. There's a couple of different ways to do this, legacy, but just one of the easiest ways is just under descriptive statistics and crosstabs. So I'm going analyze, descriptive statistics, crosstabs. Okay, so it's up to you of how you want to do this. The sex was row and the willingness to use health services was column. And now it's very important here. I want to look at my statistics here, and I want to define these statistics. So we're interested in the chi-squared, that relationship. We want the Kramer's phi or v, the measure, the effect size measure, and we want both those. You could ask for some other things as well, but those are two you need to click on: chi-squared and phi and Kramer's v. Phi and Kramer's v is really the same thing. The broader general aspect is Kramer's v, but in a 2 by 2 case, it's actually phi. So we're talking about the same thing. Phi is just a generalize for the 2 by 2, but really it's after Kramer's v here because we have a 2 by 3. Go ahead and press continue. Now we want some other information coming off the cells as well. So I clicked on cells, and we want the observed and we want the expected. Now, depending on how you're presenting this data, you might also want some percentages of rows and columns. That's very, very helpful sometimes. But we're going to go after observed and expected. Continue. And then I'm going to go ahead and click OK. Okay, so this gave us our analysis for this project, for this example. And what I'm going to do is go ahead and pull these tables right in the assignment, and you can too as well. So they're right in there. So I don't need the top one, but I'm going to start with cross tabulations. Bring that right over to my assignment. I'm going to bring over the chi-squared test. Again, I'm just copying and pasting those over. And finally, the symmetric measures. Paste. So now I'll go ahead and minimize my SPSS, and I have that information in my assignment. Okay, so as we look at our table for our analysis, right here, here's our sex, and it's swapped them, females, males, males, females. We could add an option of which way to do that in the analysis. It won't really matter for us. We're just after an association. So now what we're seeing here is count, the actual observed frequency for the two variables, and then we see the expected count. To get this 45, what you would have done is taken the row total, 90, times the column total, 75, divided by the total, 150. That would give you the expected frequency for that cell. In the assumptions of the test, we always want those expected frequencies to be 5 or greater. This is also telling you where you'd expect things. So like in this case, if it's just random variation, we would expect 18 in this cell, but we actually got 13. So after, if you're statistically significant, you can go through and look at where that's really different. Like here, under maybe and males, we see we get 30, but we'd expect 75 if it was just due to chance. So there's definitely something going on there that we're getting fewer males than we probably should be under the maybe aspect. Okay. So then the chi-squared test itself, the Pearson chi-squared, here's its value. It's degrees of freedom for the tables. We have a degrees of freedom 2 here because we had row minus 1 times column minus 1, as we saw in the text, gives us the initial degrees of freedom for the table. And then the p-value here, assuming a two-tailed test, and is this less than 0.05? Yes, it is. So this is statistically significant. We're getting our Kramer's v down here at 2.34, and we're saying that same statistical significance down here. So what we're showing here is there is an association in this table, or a lack of independence, or the independence for this table, and it's no wonder why when we see like 30 versus 75. All right, we're expecting 30, but we actually have 75. I think I said that a little different last time. We're expecting 30, but we have 75, so a lot more in here. So that's kind of association we're finding here. So then we can go ahead and write this up then. In APA, we would say, the results showed statistically significant difference for association or independence. And we would say it's chi-squared. Now, I'm going to just write chi-square and open parentheses, the degrees of freedom associated with the test are 2, and we often put our n in here. And again, the text says 50, but really it's 150. And there's different ways sometimes you can write this, but we're really getting a 150 here. So that text, in my mind, would be inaccurate. And the value of the chi-squared was 8 point, we get that right up here, 8.2. And the text just carrying it out to hundredths, so 8.23, comma, and our p was less than 0.05. And we give our Kramer's v equaled 0.23. And we're getting our Kramer's v right here. Okay, and that's all there is to the chi-squared here. Again, very useful and can be used in a lot of situations. And that's how I want you to report this assignment, just like this. So thank you so much.